Okay, so this is June 2008, question 2 from paper 6, which again is the fusion fission type question. And it starts again with state with detail this time 2 other advantages of nuclear fusion as an energy resource. There's a wee bit of blurb at the start, and then we're looking for the difference now. This question has come up in recent papers just before this. Twice already in recent papers, so it's a question that the examiner is looking at for quite a lot, and the answers have always been that there's an almost limitless supply of fuel, or an abundant supply of fuel, and secondly that there's no long-lived nuclear radioactive waste. So no long-lived radioactive waste. So they're looking for 2 of those advantages with detail. So we're going to state the advantages first of all. So the first advantage is that there's an abundant fuel supply, or an almost limitless fuel supply. So it's almost limitless. And why is that? Well, because we can get hydrogen in the form of deuterium, the fuel that's required. So it's deuterium and lithium, remember, is the most common fuel mixture that we use. So deuterium found in water, lithium in the Earth's crust. So there's an abundant fuel supply, or an almost limited supply, where we can get deuterium from water and lithium in the Earth's crust. And then the second point is, whenever we consider it, we have no long-lived radioactive waste. And the explanation for that is that there are no fission byproducts. So there's no fission products, and therefore handling problems are less difficult. So something along those lines there. The explanation of that one's not as great as the explanation of the first one, but the same. Then goes on to ask about a confinement technique. This time it's the tokamak, which uses a magnetic confinement technique, and it's really asking about that magnetic confinement. So the tokamak in the jet reactor isolates the plasma from the walls of the containment vessel. Explain how this is achieved. Well, this is achieved by using a toroidal. Remember, a torus is the donut shape that it uses in the tokamak. So we have a toroidal magnetic field is applied to the charged ions in the plasma, and then these ions are forced to spiral along the magnetic field lines, and that keeps them away from the sides of the vessel. So remember that we've got this spiral motion as it goes around. As it goes around the torus, it goes around in the spiral motion, which keeps it away from the sides. And then the final part of this question is, give another reason, in addition to plasma containment, why it is very difficult to achieve fusion on a large scale on Earth. Now, this is an interesting question because there's 2 marks for it. So although it says give another reason, it's actually looking for 2 reasons here. The first reason is fairly obvious, and that's the need for a high temperature. So the need for very high temperatures, extremely high temperatures, is the first and most obvious reason for that. And you would think that you would get your 2 marks for that, because it's only asking for another reason, but the examiner was looking also for you to say that there's a need for a long confinement time. So need for high temperatures and need for a long confinement time in order to get nuclear fusion to happen.